Okay, so you need to find the notes that look like this.
Okay, I'll speed it up. Don't worry.
So hard.
I'm gonna put it in. What's hard?
This looks hard. Too many words.
All right, so these are the notes that you're going to be looking for. We've got something that we're going to talk about, titration. And the primary equation that you're going to be using for this. It's just exhausting. I'm just so tired of the spinning wheel. So primary equation that you're going to use for this is this M1. We talked about it before. Is this M1 V1 equals M2 V2. And in this case, one side is going to be your acid, and the other side is going to be your base. Okay? And when we can get these things, we can use this to kind of figure out where our equivalence point is. And we do that with a variety of different pieces of equipment. So one of the ways that we do that is through something called a titration. So your titrations are a technique where you're going to look at the molarity and the volume of something called the titrant. And typically that is dispensed from something called a burette. So this is what a burette looks like. It is a long, skinny tube. And when we are doing that, so we've got our burette here. So this is our burette. And we've got a couple different things that we can use to analyze when we're using these burettes and titrations. One of them is an acid-base titration. And the thing that you're dispensing out and you're measuring is called your titrant. And then the thing that's down here that you're analyzing and trying to figure out the molarity of is called your analyte. And you're trying to use an acid-base indicator that changes color at the equilibrium point. Now for you guys, you're going to be doing a strong acid, strong base. So that equivalence point is going to be 7. Okay. If you're doing other things, like if you were doing a weak acid and a strong base, the equivalence point would be above 7. Okay. Sometimes you use pH meters. We'll use pH meters if you follow me into AP Chem. We do one with that in there. Redox titration is another one where you're looking for a color change with the oxidation state with the different metals. We'll talk about, we actually do one of those in AP as well. And then there's a precipitation titration where you're trying to figure out at what point do you get a precipitate to form. We don't usually do that in either one of the classes. So what are the pieces of equipment? So like I said, you're going to have a burette, which is one of these long, skinny tubes. These long, skinny tubes are marked off in a variety of different measurements. And you measure to the 100th place using these burettes. At the bottom of the burette, you have something called a stopcock. This spins around so that it's going to change the flow of the titrant going through here. So if you want it full on, it's going to be straight up and down. If you want it full off, it's going to be sideways. And then you can move it anywhere in between to get a very slow drop to form. So if you're close to that equivalence point, you probably want to kind of slow it down. That's how you would do that. You load these burettes at the top. We call it loading them. So you use a funnel typically to load the burette. If that funnel spout reaches down into the measurements, you've got to make sure that you remove that before you do your readings, because it will affect. If it's really close to the top, it's going to affect the reading. All right. Volumetric pipette. You use a volumetric pipette to dispense your analyte. Otherwise, you can use another burette setup. So here I have an acid on one side and a base on the other. So you can dispense from this guy, and then if you overshoot, you can just go back and add more, and then you're just dispense base on this side. This is called a volumetric pipette. So with this, typically you'll have a thing that you put around your wrist, because then you can just instead of laying it down, you just let it flop here, because you pick this up and down a lot. Okay. And what you do is, if you have your beaker of material that you're trying to get to suck up, you take your volumetric pipette and the bulb, and you're going to squeeze this. You put it over your pipette, and with your other hand, you're going to, have you ever played the game where you like suck up something with a straw and then you put your finger over the straw? That's what you're doing here. Okay? Except you're not doing it with your mouth. Yeah. So back in the day, we actually did use our mouths.
Oh.
Yeah.
How long ago is back in the day?
Probably back in the late 80s. But now they make you use these. I know, they've sucked all the fun out of it. Okay. So you start drawing it up with the bulb. So you put the bulb up over the clothes here. You draw this up. You want to try to, and I'm just playing with water right now, but you want to try to get that all the way up without actually sucking it into the bulb, which is a little bit of a trick. And then you want to cover it with your thumb. And it's going to be above that line, you're hoping anyway. And then you slowly release it, and you're trying to slowly release it until it gets to the 0 mark. And it's a little bit of a game. Oh, I overshot it. So then you have to go back, more up, restart, and you have to keep playing until you get it right where it should be. I've got liquid up in this thing now. Yeah. But tomorrow you guys are just playing with water. I just want you to play with water and kind of practice some of this stuff. There, I overshot it again.
What day is it tomorrow?
Thursday, Cinco de Mayo.
All
right, there we go. I got it perfect 0 now. Now, when you do this and you dispense it, all you have to do to get it to, you put it over whatever place that you want it to dispense into, you're going to let it go, and that'll give you a perfect, this one happens to be a 2 mil. There's always some left in the tip, and these are designed that's okay. Okay, this is called to deliver. So they're saying that if you dispense this out and you have that little bit left in the tip, then you've got an exact 2 milliliters. They've taken that into account. So that's what it means, to deliver. And it says TD on here. And then if you want to clean it out, you just kind of squirt it, turn it upside down, and then let it dry. Okay, does that make sense with these? But yeah, we used to mouth suction. It was called mouth suction. Oh, I'm still here. Okay, I got water on my desk now. All right, let's see here. All right, so we went through the burette, we went through the volumetric flask. Sometimes you have to, like with a redox titration that you're going to do at AP Chem, you need a balance to be able to measure out that sample. Erlenmeyer flask is typically used to catch the sample in the bottom here. And the reason why we use an Erlenmeyer flask is because then you can swirl very easily inside there. And then acid base indicator, which yours is going to be phenolphthalein. That was the one that you used on Thursday of last week that turned the bright pink. And then pH meters are sometimes used. So what is needed for you to record in the process of these? You're going to want to know the molarity of the titrant, the initial volume of that titrant, and then the final volume of the titrant. And then you also need to know whatever you're analyzing, you need to know the mass or the volume of that particular thing. And what you do is you titrate in. So if this was a strong acid, you're going to titrate in until you get to that perfect point, which is called the equivalence point. That's where for the phenolphthalein, it's just the faintest shade of pink. So just the absolute faintest shade of pink that you're going to want for that. And that's going to be your equivalence point. You're going to, pH is going to be approximately 7 there. Then you look to see how much of the base that you added to get to that point. Okay. What's wrong?
Huh?
What's wrong?
It looks exactly like the calc graph I did yesterday.
Oh.
I'm sharing. Sorry, continue.
Well, in AP, we actually take these and we do derivatives and second derivatives with it.
Wow.
So, well, we don't. The computer program does, because Lippy doesn't know how to do a derivative. But
Just need a function.
yeah, you're just going wah 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 to me. So,
Wow, 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 wow.
but at any rate, we do that with these graphs to be able to figure out data for it. Yeah. So.
I remember that on the AP test.
All right, so I also want to take you over. I had some other stuff opened here, but then I had to reboot my computer. So these burettes read kind of funny. So it's kind of a harder concept to sort of wrap your brain around. When you are working with a burette, the numbers at the top are lower than the numbers at the bottom. Okay, so it counts up as you go down. So for example here, if I wanted to know where the meniscus was for this, this would be 19, 19.1, 0.2, 0.3, 0.4, 19.5, and then if it's right on the line, it's going to be 0. So you go to the 100th place with these burettes. Now here's another one. This would be 19.5, 19.6, 19.70. Oh, that one's not big enough for you guys to see well. All right, so here, if you start at exactly 0, then you can figure out whatever amount you land on is how much you've dispensed. That's why they do these backwards, because if you start out at exactly 0, then you're dispensing down, you know exactly how much you've used. That makes sense? So this guy would be something like 22, 22.1, 22.20. And that last digit is always, you know, a guess. So here, this would be what? This is 17. Okay. All right. Does that make sense? So with these, it always has, do you see how this line in between is a little bit wider? That's the half. So this is 48.5, 48.6, 48.7, 48.80. So this will get you halfway there if you're below that halfway point. Does that make sense how to read these?
Yeah.
Okay. It does take a little bit of practice, and you kind of have to fight your instinct with them. All right. What did I do?
Kendall looks like she's dying.
So you've got some problems here, 18.5 and on, that you can work with. If you've got questions, let me know. I'll get the answer key up here for you in just a minute. I don't have it printed out. So that is essentially what we're going to be working with tomorrow. Tomorrow you're just working with water. On Friday you're actually working with acids and bases, so you have to wear your goggles then.
I will.